Michael Faraday, 1791 to 1867, was one of the most influential scientists in history, whose groundbreaking contributions in the fields of electromagnetism and electrochemistry continue to shape modern science and technology. His discoveries laid the foundation for the development of numerous technologies we rely on today, from electric motors to the understanding of light and magnetic fields. Though he lacked formal education, Faraday's extraordinary intuition and experimental skills made him one of the most respected figures in the scientific community. Born in London to a poor family, Faraday's early life was filled with hardships. His father, a blacksmith, was unable to provide a stable income, and the young Michael often had to help with family chores. However, Faraday's curiosity about the natural world was insatiable. He received only a basic education, but his talent for understanding complex scientific principles became apparent at an early age. In his teens, Faraday secured an apprenticeship as a bookbinder, which led to his access to scientific literature. This was a pivotal moment in his life, allowing him to educate himself in the sciences and inspiring his interest in physics and chemistry. Faraday's path into scientific discovery began when he attended lectures by the renowned chemist Humphrey Davy in 1812. Faraday was so inspired by Davy's work that he became an assistant to him at the Royal Institution. This marked the beginning of a long and fruitful partnership. Despite his lack of formal academic training, Faraday's innate understanding of chemistry and physics led to remarkable discoveries. Davy recognized Faraday's brilliance and mentored him, allowing him to carry out groundbreaking experiments that would go on to transform the scientific world. In 1821, Faraday made his first major contribution to science with the discovery of electromagnetic rotation, which demonstrated the relationship between electricity and magnetism. Faraday's work showed that a magnetic field could produce an electric current, and this concept would later become a crucial element in the development of electric motors. His experiments with magnetic fields also laid the groundwork for the theory of electromagnetism, which was further developed by James Clerk Maxwell. Faraday's pioneering work in electromagnetism continued in the 1830s when he discovered electromagnetic induction, a phenomenon where a changing magnetic field produces an electric current. This discovery was essential to the development of electric generators and transformers, technologies that are vital to the power grids we use today. Faraday's work also led to the invention of the electric motor and the dynamo, devices that revolutionized industry and technology. In addition to his work on electromagnetism, Faraday made significant contributions to the field of electrochemistry. In 1834, he discovered the laws of electrolysis, which explain how electric current can break down chemical compounds. These laws have become fundamental principles in the study of chemistry and are still used today in the extraction of metals and other industrial applications. Faraday's contributions to science were not limited to theory. He was also an exceptional experimentalist. His ability to design and carry out precise experiments was instrumental in the advancement of scientific knowledge. His work in isolating benzene, discovering the principle of the Faraday cage, a conductive enclosure that blocks external electric fields, and his research on the nature of light all further cemented his reputation as one of history's greatest scientists. Despite his monumental achievements, Faraday remained humble and never sought recognition or wealth. He was deeply religious and believed that science was a way to understand the divine order of the universe. Faraday also took on a mentorship role, encouraging young scientists and fostering the next generation of researchers. Faraday's legacy extends far beyond his numerous discoveries. He was a visionary who saw the interconnectedness of different branches of science and sought to understand the fundamental laws that govern the natural world. His work laid the foundation for many of the technological advancements that followed, including the development of radio, the telephone, and modern electrical systems. Faraday's contributions to science were recognized throughout his lifetime, and he was honored with numerous awards and accolades, including being elected a Fellow of the Royal Society in 1824. Even in his later years, Faraday continued to make valuable contributions to science. He served as a professor at the Royal Institution, where he conducted his famous Christmas lectures, inspiring generations of students and scientists. Despite suffering from health problems in his later years, Faraday remained dedicated to his work until his death in 1867. Today, Michael Faraday is remembered as one of the most important scientific figures of the 19th century. His discoveries laid the groundwork for the modern electrical and electronic industries and continue to influence scientific research in a variety of fields. Faraday's legacy is a testament to the power of curiosity, perseverance, and the pursuit of knowledge, proving that even in the face of adversity, one person can change the course of history.